Hi. Okay, take some time to read this question. Okay, now very simple. I shall draw the model, I shall draw the diagram out. It's not going to be too difficult. Okay, imagine that this is a tanker and we have a big pipe here and we have a small pipe here. Alright. Okay, I'll let this big pipe the time to fill up the tank, let it be x, and the time here, because it takes 6 hours more. Okay, the big pipe, the larger pipe alone takes 6 hours less. Okay, I beg your pardon, there should be an hour here, 6 hours less than the small pipe. Okay, so this should have been x plus 6. Alright. Now some of the students, the commonly made mistake is x plus 6 equal 4. Why? Because they will take 4 hours to fill up the whole tank. So if I add them together, or if I were to attempt solving this question, it will end up like that. 2 hours is equals to minus 2 and x is equals to minus 1. Now this answer is ridiculous because that means x is negative 1 hour. If we were to start filling up the tank at 9 a.m. we would have finished it at 8 a.m. Now what's wrong with this equation? Now there's nothing wrong, note something, there's nothing wrong with the working here. Alright, nothing wrong, but it's the construction of the equation that's already wrong. I try to teach my student in this way. Imagine we have more pipes coming in. Alright, more pipes somewhere, more pipes, okay, more pipes, more weird looking pipes. Okay, maybe we have 5 of them. If we were to add all the timing together, let's say this is 8 hours, this is 2 hours, this is 5 hours, that's half an hour. If we add all of them all together, then we would end up having a very long time, don't you think so? But by adding more pipes, we should have a shorter time, or we should get it done in a shorter time. So it's not wise, or should I say it's not logical to add all the timing together, but rather we should add the efficiency together. Now what do you mean by that? Okay, just give me a minute. Okay, imagine we have a tanker this way, and we have a pipe here, and we have a pipe here. Okay, let's say in this case, this larger pipe takes 2 hours, and this smaller one takes 8 hours. Alright, there's a 6 hours difference. This is not the answer. Now in 1 hour, okay, it takes 2 hours for this pipe to fill up the whole tank. In 1 hour, what is the fraction of the tanker being filled up? Well, it has to be half, right? Then 1 hour later, another half, the whole tank will be filled up. 8 hours, well, it has to be 1 hour later. What is the fraction of the tank being filled up? Well, it has to be 1 over 8. You just give it 8 hours, just 1 over 8, 1 over 8, 8. 1 over 8, you get 1. Now in this case, if I were to turn on the 2 pipes, can I possibly add them together? to get my new fraction being filled up per hour? Can I do that? The answer is absolutely. Right? So pause for a moment, think how you should proceed solving this question. In the meantime, I will have to erase those that are not necessary. Okay, I hope when I'm erasing my work, you're doing a bit of thinking. Okay, and this as well. Okay, now. Okay, let's get back to my pencil mode. Okay. So over here is almost the same thing. In this case, what we have is x. So okay, can you remember if it's 2 hours, it's 1 over 2. If it's 8 hours, it's 1 over 8 of the tank per hour. So in this case, what we have is 1 over x plus 1 over x plus 6. Now most students would do this. x plus 6, so times x plus 6, so times x plus 6 plus times x times x times x. So I hope you know what I'm doing. Okay. Alright. Okay, then they got stuck here. And the reason why they got stuck here is because what they have is an expression. It's an expression. And what they need is an equation. Because it has to be equal to something, I have to equate this to something in order to solve it. Equate to what? Then we have to look at the info here, 4 hours. We have not made use of these 4 hours. How do we make use of these 4 hours? Is this equal to 4? Well, the answer is, is it equal to 4? Well, the answer is no. Why not? Because this is efficiency per hour. What's the fraction of the tank being filled up in 1 hour? Well, since with the 2 pipes, it can fill up in 4 hours, so can I assume that, maybe I should do this. Can I assume that in 1 hour, 1/4 of the tank is filled up? And at second hour, another 1/4, another 1/4, and finally another 1/4. Can you see that? 1/4, 2/4, 3/4, 4/4, and that makes 1 whole. So what it should have been is 1, oops, is 1/4. And if you solve this equation, you will get the answer. Now for those who are not very sure of this question, you can always call me at 65630555. Alright, for more information. You know who I am. My name is Yuman. Thank you very much.